Okay, final page here. This first problem is asking you about conic sections. Just a quick reminder that if you have something like this is equal to r squared, that's a circle. And so anything that has x squared and y squared with a plus between it will be circular of some form. In this case, this one is an ellipse. So you can Google this if you need some more information about this. It should be somewhat of a review from pre-calculus and calculus 2. The center of this ellipse is going to be at the point -2, 5. And this is just coming directly from there. And then the values for the semi-major and semi-minor axes come from this. So here I'll just write it like this: a squared, b squared. In this case, a is the semi-minor axis. Well, major, I guess. Whichever one's bigger is the major axis. I don't like to make a big deal of it. You can figure it out. The bigger number is the major one, the smaller one's the minor one. Okay, so anyway, let's put this down. Center at -2 and 5. Oh yeah, so here a is equal to 3 and b is equal to 2. Okay, -2 and 5 puts us right here. That's the center. Now a equals 3, that's under the x, so we're going to go 3 units in the x direction on either side. And then the 2 there means we go 2 units in the y direction. And you can just connect the dots with a nice oval and call it a day. So that's an ellipse. I'm sure I could do a better job if I was more careful, but that'll do. This next one, the big difference between these two is that it has a minus instead of a plus. This will be a hyperbola. And same center, because everything else is the same. And so we'll start with the same sort of sketch. Let's see, trying to get this in the same position. We'll draw the same 4 points around the center, but now instead of connecting them, we're going to draw a box. And that box is going to guide us as we draw the hyperbola. So this one is a hyperbola. This hyperbola will open up in the direction of the positive, whichever one is positive, whichever of these variables. So here the variable x is positive, so this thing will open up in the x direction like this and like that. All right, moving on. 2 more. We have the water and the river. Okay, let's draw this situation. We have a river, and the water is moving south, so we'll say south is that direction. And we're going 10 miles per hour. At the same time, a motorboat is trying to go across, let's see, a speed of 20 miles per hour due east. So let's go like this, 20 miles per hour. Well, this one's actually quite easy. You have the water, which we'll call the w vector, 0, -10. And then the boat, we'll call that the b vector, is 20, 0. And we're going to add those together. The boat plus the water is the result, is 20, -10. And we need to know the speed. So the actual speed will be the magnitude. So we'll call that a for actual. So the magnitude of this actual thing is the square root of 20 squared plus -10 squared. And that's going to be 400 plus 100. And that gives you 10 radical 5 after simplifying. So that's the speed. And then direction. Let's see how we're going to do this. We'll do an angle. So let's see. I'll do this. So that's the actual. So here we'll call this the water. That's actual, and this is the boat. So this actual, well, let's measure that angle there. That's easy enough. The tangent of that angle is going to be opposite over adjacent. That will be 10 over 20. So that's 1/2. So arctan of 1/2 will be the angle. I'm just going to leave it like that. So to be clear, you're going south of east. So some people might quibble and say that they want that angle to be written as a negative angle, but I think given the way I've drawn the diagram, I think I'm fine with the angle that way. So as long as you're clear about what you're doing, communicate well, you'll be okay. Last one, 2 people pushing a box. So here, you're not given any direction or point of reference. And so I'm going to have one of the people pushing the box along the, so we're going to do a top down. So we're looking down on this box. And one of the people will be pushing the box. How about, I don't like that. Let's go this way. So from left to right. And then the other person, it says that there's a 120-degree angle. The other person will be doing this. Let's see, one person, we're going to do this, the 15 Newton, and this will be the 12 Newton. Now those vectors, of course, can be drawn in any position. So I'm going to redraw them like this. So we have 15 Newtons, 12 Newtons, and here's this 120-degree angle. So now it's just a matter of converting these to Cartesian coordinates and then adding them together. So if you give me a minute, the first one is going to be 15, 0. That's why I chose that. So that's person A, we'll call it. So the vector A. Vector B is going to be the vector, 12 times the cosine of 240 degrees and 12 times the sine of 240. And we all know what the sine and cosine of 240 degrees is. So I'm going to put that in here. So that'll be 12 times negative 1/2 and 12 times, wait a sec, sine of 240. Yeah, I think my diagram just doesn't look good. That's going to be radical 3 over 2. Oops, there we go. And so that's going to be negative 6 radical 3. Let's add those together. So once these, if they could push the same direction, they'd probably make more headway, but here we are. So when we add these together, I get 15 minus 6 and negative 6 radical 3. So that's going to be 9 and negative 6 radical 3. What does it say we want to do? What is the magnitude? Okay, magnitude is easy. So we'll call this C, the resulting force. Now we'll just do the magnitude. 9 squared plus 6 radical 3 squared. So what's that? 81 and 108. So 189. Sadly, that is not a perfect square. So we'll just leave it like that. So there's the magnitude in newtons, and then the direction. And let's be clear about this on the diagram. Remember, try to communicate well. So when you add these together, you'll get something like that. So that's going to be C. So we'll call this A, B, and C. And so let's get this direction. So the direction, what I'll do is I'll compute this angle right there. We'll call that theta. Just a minute. Theta. Okay, so theta is the arctan. And I guess this is going to end up being a negative angle, so unlike the other one. But once again, let's just communicate clearly when we do this. This will be the arctangent of negative 6 y over x. So you can draw it on here. Draw yourself a little right triangle if you need to. And this is about the best we can do since we're not letting you use calculators. I'll just clean it up a little bit. So 2 radical 3 over 3. And that's it. All right, don't forget to smash that like button.